Okay, our last lesson on exponential models was over exponential growth and decay. It was a lesson with the organisms and the bacteria. Today we're talking about money, and we are working primarily with this formula. And I have written up here what each of the variables represents. So if you need to pause your video to write all that down, I'll zoom in and you can go ahead and do that now. The A is for accumulated or total amount of money in an account. P is for the principal or beginning amount of money. R is for the rate of interest. And remember, that's usually given as a percentage. So if you had 7%, before we can do math on it, we would want to divide it by 100 and move the decimal 2 places to the left. N is equal to the number of times that interest is compounded per year. In other words, how many times it's calculated and added back in to the original amount. And then T is the number of years that the situation is occurring. So I'm not doing the whole packet, just a few problems for examples. In this first one, it says, for your graduation present, you receive $500. You decide to invest this money in an account which earns 6% annual interest compounded monthly. And part A is just asking us to find the equation which describes the amount of money in the account as a function of time. So what we're going to be doing is figuring out from the problem any constants that we can substitute in for the variables. Now A is going to stay A because that changes over time and it's not a constant, but the P variable, hi.
Thank you.
P we know is the $500, the beginning amount. 1 is 1 plus R. The rate is 6%. We want to divide that by 100, which means moving the decimal 2 places to the left, making it 0.06. N is in 2 places, and we're going to use the same number for both. That's how many times a year the interest is compounded. That means the interest is calculated, it's added back to the principal amount, and then now that's your new accumulated value, and how many times a year that process occurs, calculating the interest. And so compounded monthly, I wrote right here that N is the number of times compounded per year. So monthly would mean that it's compounded 12 times per year. So N goes here in the denominator and then here in the exponent, and then T can change depending on the situation, so that's going to stay a variable. So we have our constants put in, and then now we have this equation for the situation that we can use to calculate other kinds of situations, like what if it was in there for 5 years, or how long would it take to triple, or something like that. Now we can use this equation. So part B asks us how much money would be in the account after 8 years. So this means T is 8. So we just plug it in where the T is. So the exponent is 12 times 8. You can use Desmos to do this. If you're in class with a graphing calculator or you have a graphing calculator, you can do that. But this will make our accumulated value approximately $807.07. And then C asks, how many years would it take for the money to double? So this means we're not plugging in anything for T. We're going to be solving for T. And when the money is doubled, that means the accumulated value of the account is 1,000. So we're going to put 1,000 in for A. Oh, sorry, this was supposed to be 0.06 right here. My bad. 0.06 over 12 times 12 to the T. Now, because the variable we're trying to solve for is in the exponential spot, we know that at some point we are going to have to rewrite this as a log, which means we need to isolate this piece. This is the base with the exponent. We need to get this by itself, but right now it has a times 500. So I'm going to start by dividing both sides by 500. And now I have 2 equals this. I'm going to calculate or simplify the parentheses right here. 1 plus this fraction, 0.06 over 12, is approximately 1.005. And I lose some accuracy when I calculate that decimal. The reason I'm doing that is it just makes it easier to rewrite the next step as a log. So now I'm going to rewrite using my lasso log base 1.005 of 2 equals 12t. So log base 1.005 of 2 equals 12t. And now to solve for t, I just divide both sides by 12. Do this in your calculator, either Desmos or a graphing calculator, and you will get approximately 11.6 years. So I want you to pause your video and try all of number 2. It works just like number 1 did. And then come back to the video and check your answers with mine. Okay, here is my work. And pause the video and check yours and make sure you understand what's happening. All right, I'm going to work one more problem for the video, and then the rest of the problems will be yours for practice. And it's going to be number 3 on the next page. An investment service promises to triple your money in 15 years by compounding the interest daily. Problem A asks what interest rate is needed to accomplish this. So I'm going to copy over the formula here from the front. So if we're being asked to find the interest rate for the situation, that means I'm going to need to solve for R. I want you to remember that in the previous problem, when we were asked about tripling or doubling our money, whenever we divided off the principal amount to both sides, we got 2 or 3 here on the left. That was not a coincidence. That will work like that every time. So in this situation, before I even start plugging stuff in, because I probably should have said this at the beginning, notice that in this problem, we aren't given any actual money information. We don't have a principal amount. We don't have an accumulated future amount, and that's okay. We know that the money was tripled. So remember how we talked about we're going to have to rewrite with lasso, so we're going to have to divide this constant off in the front eventually. So if I've taken my accumulated amount and divided it by the beginning amount, even though I don't have numbers, I know that this is going to give me 3 because my money has been tripled. So my accumulated amount is 3 times the beginning amount, which I've just divided it off. So that's going to equal 3. And so now I've got this left, 1 plus r over n to the nt. R is going to stay a variable because I'm looking for it. N is coming from the fact that the interest is going to be compounded daily. So I need to know how many days are in a year, and that's 365. So N is 365. And T is 15 years. Okay. So now I need to solve for R. So I'm going to start by doing 365 times 15, which is 5,475. Now it feels like we need to rewrite this as a log. And I'm going to show you that, and then we're not going to do it, but I want to talk about the problem that we run into. So if I rewrite this as log, it's log with the base 1 plus r over 365 of 3 equals 5,475. Now this is going to cause a problem. We cannot be putting a base into a calculator that has a variable in it. It won't solve it like that for us. So we need a different approach. So I'm going to show you something simpler. Let's say instead of this equation, I had 3 equals r to the third power. So instead of this funky whole expression base right here, I just have one variable. And instead of a crazy exponent, I just have 3. And I asked you, what would you do to both sides to solve? Well, the inverse of a power of 3 is a cube root of 3, right? Inverses, roots and powers are inverses of each other. I can apply that same idea here, even though everything looks more complicated, the principle is still the same. To undo a power, you do the root with the same number. So I am going to take the 5,475th root of both sides. And on the left, the root cancels the, on the right, the root cancels the power. On the left, you're going to put this into Desmos or the graphing calculator. The 5,475th root of 3 is approximately 1.0002. And now the root canceled the power, so I'm just left with the base 1 plus r over 365, and now I'm just going to solve this like a regular equation. Subtract 1 to both sides. Now I have r over 365 on the right, so I'm going to multiply both sides by 365. And r is approximately 0.073. Now remember, that's the decimal version, or the version of the rate that we use for calculating, but our final answer is going to be as a percentage. So now we multiply by 100 or move the decimal 2 places to the right. So the rate is 7.3%. So now, make some more room here. We can finish out the problem. So part B asks us to write the equation for the situation. If we invest $5,000. So now we have a principal amount of 5,000. The rate is 0.073 and is 365. And t is going back to just being a regular variable. How much money will there be after 3 years? Plug 3 in for t, and then just throw all of that into the calculator, and you should get approximately $6,224.02. And then how long will it take to double? Remember, that is going to be 2. If we already do the accumulated divided by the principal, that's going to give me 2. That's the same as 10,000 divided by the 5,000 principal amount. Times 1 plus 0.073 over 365 to the 365t. I'm going to go ahead and do this math inside here to make my rewriting as a log a little bit easier. So that's a base. Rewrite using lasso, log base 1.0002 of 2 equals 365t. Divide both sides by 365, and t is approximately 9.5 years.